Alright, so here in this video we're just looking at waves, or you can say wave motion. Okay, so this is quite an important and interesting topic in physics. Okay, so waves have got many different types of definitions. Okay, you come across different types of definitions according to the book or material you're using. Okay, but I like to stick to this one. It describes at least a lot about waves and what goes on when a wave is formed. Okay, so I'll use this definition. We'll stick to this definition here. A wave is a disturbance or vibration in form of energy traveling in a medium or space. Okay, we are talking of an empty space here. Okay, you could also refer to it as a vacuum. Okay, as a vacuum. Okay, so from the definition here, we're saying a wave is a disturbance or a vibration. Okay, and we'll get into that in a few minutes, in form of energy. Okay, so a wave transmits energy as it's moving. Okay, it transmits what? Energy, or it's in form of what? In energy. Okay, so if you've seen some waves, okay, so I have a diagram here with me. So these are waves formed on water. Okay, so these waves are formed on water. Okay, so the same principles apply here when you're looking at waves in physics. Okay, so when you see water waves like that, okay, so it's just the same principle. Okay, so now from our definition here, we can say that we have two types of waves. Okay, some require a medium. Okay, so we say traveling in a medium. Okay, or what? Or space, or a vacuum. Okay, so this leads us to two types of waves. Okay, number one, we've written down here mechanical waves. Okay, mechanical waves. So what are mechanical waves? Okay, so these waves require a medium such as water. Okay, we can just say require a medium such as solids, liquid, and what? And gases. Okay, so here we know that mechanical waves, for them to be propagated or for them to move, okay, they simply require a medium. Okay, a medium. So these need a medium, and when we say medium, we're simply talking about the three states of matter. Okay, which is gas, liquid, and also solids. Okay, so solids. Okay, so the three states of matter. Okay? So mechanical waves, these require a medium, okay, to travel through. Okay, and we have examples. Okay, so let's look at the three states of matter first of all. Okay, so we have a diagram here showing us the three states of matter: solids, liquid, and gases. Okay, and we know from kinetic theory of matter that all these three states of matter, solid, liquid, and gases, consist of what? Tiny particles. Okay, they have tiny particles. As you can see, you have the particles shown there in solids, okay, in liquid, and also in what? In gas. Okay, so one interesting thing here, when we pay attention to the particles, the way they are arranged, okay, the arrangement of the particles in solids there, you find that solids are closely packed, or they are stuck up together. Okay, and then in a liquid, there are a few spaces, okay, few minimal spaces. Okay, and the liquids are free to move about short distances. Okay, and we have gases where the particles are, randomly, okay, far apart from each other, and there is free movement here in gases. Okay, so now what happens is that, since we said a wave can travel in a gas, okay, in a liquid, and in a solid. Okay, and in a solid. So what happens is that when mechanical waves are formed, okay, they transfer energy. Okay, they transfer energy by causing the particles in this medium. Okay, they cause the particles in this medium to do what? To vibrate. Okay, so they simply cause the particles to vibrate, and we'll get into that. Okay, since we defined the wave as a disturbance or a vibration. Okay, so the particles in a solid will vibrate. Similarly, the particles in a liquid will also vibrate, and the particles in a gas will also vibrate. Okay, so mechanical waves transfer energy by causing particles in a medium to do what? To vibrate. And an example of mechanical waves, okay, there are a lot of them. I can give a few examples about mechanical waves. So we can say example given there. We have water waves. I showed you the diagram there. Water waves. We also have sound waves. All these are type of mechanical waves. Okay, so all these are types of mechanical waves. Okay, so apart from this, okay, since we said traveling in a medium or a vacuum or what, space. Okay, so now we have others that can travel in space. They do not require a medium. Okay, they do not require a medium. Okay, so waves that do not require a medium, we call them electromagnetic waves. Okay, so there are two main types of waves. Okay, electromagnetic waves as well as mechanical waves. Okay, so we said mechanical waves require a medium for them to be transmitted. Okay, and they carry with them energy that can be transferred by causing the particles to vibrate, and we'll get into that. Okay, so electromagnetic waves, these do not require a medium, and they can travel through a vacuum, okay, an empty space. Okay, these do not require, okay, do not require, what's the key word here, do not require a medium. Okay, do not require a medium, so they can travel without a medium. Okay, and we have a lot of these waves. Okay, it's a topic on its own, electromagnetic waves. Okay, but just to mention a few examples, we can talk of light waves. Okay, the visible light. We can talk about radio waves, and do of course get into these. Okay, light waves, radio waves. Okay, we have X-rays, gamma rays. So electromagnetic waves are characterized by, we'll look at this property. Okay, they have some few properties. Okay, they have varying properties. Okay, such as frequencies. Okay, varying properties such as frequencies as well as wavelengths. Okay, and we'll look at that later. Okay, so we have these two types of waves. Okay, so from the definition here, just this part here, we can see that we can get a lot of meaning. Okay, we can get a lot of meaning just by saying that waves travel, okay, either in a medium or a vacuum. Okay, and we've seen that this gives two types of waves. Okay, electromagnetic waves and mechanical waves. And under mechanical waves, we've looked at, we've talked about water waves and sound waves, and these require medium for them to be transmitted. Okay, so let's look at the other part of our definition here. We said disturbance. Okay, it's a disturbance. Okay, it is a disturbance. Okay, that's wonderful. Okay, so we said it's a disturbance. Okay, so now we can give an example here. Let's say we have a scenario here. You can see this man there disturbing the water. Okay, is making a disturbance on the surface of the water. Okay, is making a disturbance on the surface of the water. Okay, so this disturbance causes water on the surface near that point where he's disturbing, okay, or hitting with whatever he has in his hand. Okay, so this disturbance causes water on the surface near that point to move. Okay, and which in turn this causes points further away to move. Okay, so let's look at what is going on in this other diagram here. Okay, so in this way, the waves travel outward in a circular pattern, okay, away from the original disturbance. Okay, so where is disturbing? Okay, so you have a point of what? Of disturbance. Okay, let me just try to illustrate this. Okay, say this is the point of disturbance. Okay, and that's where the man is what? Is hitting. Okay, that's the point of disturbance. Okay, so these waves will start traveling. Okay, will start traveling to other areas. Okay, transmitting what? Energy. Okay, transmitting energy. Okay, so it is a disturbance. Okay, so find that the particles, usually the particles, you would find them, they're in their rest position. Okay, they all start up in their rest position. Okay, or what we call in equilibrium. Okay, and we'll show you that in a bit. Okay, so now we've seen that these waves are formed when there is a disturbance. Okay, so mark this as a disturbance, or there is a vibration. Okay, or there is a vibration. Okay, so we've talked about a disturbance. So let me just illustrate something here before we dive into something else. Okay, so we said it's a vibration. Okay, we said it's a vibration. vibration or disturbance. A disturbance. Okay, so for us to understand this quite well, let's just present so let's look at this diagram here. Okay, we have two types of waves. Okay, or before we look at the two types of waves, so let's look at the term vibration itself. Okay, vibration. Okay, so under vibration here, when particles begin to vibrate, they can vibrate in two types. Okay, so number one, you find that particles will vibrate up and down. Okay, and some other particles will vibrate to and fro. Okay, or you can say they'll vibrate back and forth. Okay, it's the same thing that is going on here. Okay, so so now this takes us now to two types of waves based on the vibration of particles. Okay, so based on the vibration of particles, okay, based on the vibration of particles, you have two types of waves. Okay, and number one, you have waves that we call transverse waves. Transverse waves. Okay, secondly, you have waves we call longitudinal waves. Okay, so based on the vibration of what? Of particles. Okay, so when we cause a disturbance, okay, particles begin to vibrate, and these particles can vibrate either, some will vibrate up and down, some will be vibrating to and fro or back and forth. Okay, so waves that will vibrate up and down, usually you find that they make up a type of waves that we call a transverse wave. Okay, so this just know that it will produce a transverse wave. A transverse wave. Okay, and the vibration back and forth, usually this will produce a longitudinal wave. Longitudinal wave. To get to that. Okay, so let me illustrate something before we go any further here. Okay, so we have, let's say, let's say this is a line. We can call this line the neutral position. Okay, you can call it a neutral position. It's neutral. Okay, or rest position. Okay, so in this diagram here, so you have these particles seated there, resting in their position. Let's say this is in water. Okay, let's say that in water, so you have these particles resting there. They're fixed in their resting what position, or neutral position, or equilibrium. Okay, so as that man was doing there, okay, here's a man disturbing the water there. Let's say he decides to disturb the water at this part. Okay, it causes a disturbance there. Okay, that's why the disturbance is being caused. Okay, so what will happen here is that these particles here will begin to vibrate. Okay, they will begin to simply vibrate, and once the particles begin to vibrate, they transmit energy. Okay, and they are able to transmit that energy, and then the waves are formed. Okay, so when this particle here, it can vibrate maybe here up, it goes down. Okay, it goes up. All of these particles will start vibrating up and down. Okay, forming such type of what? Waves. Okay, and such type of waves, okay, we call them transverse waves. Okay, so how do we define a transverse wave? Okay, so the key word here, transverse waves. Okay, these are a type of waves where the vibration of particles, okay, is perpendicular to the direction of the wave motion. So the key word here is simply perpendicular. Okay, the particles vibrate perpendicular to the direction of the wave motion. Then the key word here, okay, it's perpendicular, or you can say they vibrate at right angles. Okay, same thing, all right angles. Okay, so That's what happens here. Okay, so now let's say we have another example. We have particles resting here. Let's say this is a solid. Okay, so say let's look at this and see, we have someone here beating up a drum. Okay, he's beating up a drum. That's solid. Okay, so there are particles there that will begin to vibrate, okay, and produce some sound. Okay, so let's look at it here now. What's really going on? Okay, so as the man is hitting here on the drum set, okay, on the snare there, it's called the snare. So as he's hitting there, okay, sound is coming out, and the sound is a wave. It's on its own. Okay, and we'll look at that. Sound is a wave. Okay, so once he hits here at this place, so you have particles there fixed like that in a solid. So now these particles here, they'll start vibrating. Okay, and this type of vibration, find that this particle vibrates there, it goes back, it vibrates like that, it goes back like that. Okay, so this type of vibration, which is back and forth, okay, is what we call longitudinal. Okay, back and forth vibration. And the key word here is that the particles are vibrating parallel, okay, to the direction of the wave motion. Okay, parallel to the direction of the wave motion. Okay, so now now that we know that according to vibration we have two types of waves, we know that we have the longitudinal and the transverse. So let's look at now what's going on. Okay, so let's look at this simple animation here, just illustrating how these particles begin to vibrate. Okay, so we have the first diagram there on top, illustrating how longitudinal waves are formed. Okay, so you have those particles, okay, at equilibrium. Okay, at equilibrium they are resting like that. Okay, you can see those dotted line there, equilibrium. Then their particles now begin to move back and forth, okay, making longitudinal waves. Okay, and the other diagram there is simply showing us how waves are formed, okay, in a transverse type of wave. Okay, so this was just an introduction on waves. Okay, it's just an introduction on waves.